Welcome to Flip, lesson 2 for the 7th grade. As we look at this today, we are continuing our, I'm going to call it the review of mathematical concepts as we dive into this, I'm going to call it really a new world of mathematics as we kind of move away from the basic operations to more complex ones, because of course your minds are that much better, that much brighter than they were before you got to this book. And so you are here, you are striving, you are reaching those goals of becoming better and better. So today we're looking at properties of operations. That's a wonderful, confusing thing to say. However, these are different things that you've really gone through different ways. You probably understand these processes and use them, but we want to make sure we know the names and we can recognize them, because they're going to become super important as we move into integer work, as we move into more and more variable work to understand these math concepts. So as we start with this lesson, we start with what's known as the inverse operation. And the inverse operation applies to addition and to multiplication. And basically, inverse is the idea of the opposite, right? If I take 2 plus 3 equals 5, if I do the inverse, right, the opposite, that would be the same as 5 minus 3 equals 2. There's this relationship between these three numbers. And because I understand that relationship, I can see how that works. A similar thing goes with multiplication and division, right? 4 times 5 equals 20. And so I can look at that relationship and say, hey, I understand that since this is how it works, this doesn't look right. Looks like I made a typo. Let's see if I can move some of this stuff. All right, these should be switched, right? Get rid of that. That should be equals. This should be divided. I must have been making this at midnight or something. That's ridiculous. Uncalled for. All right, now we have something that's truly an inverse. 4 times 5 equals 20, and of course the inverse, the opposite, right? Basically, you're working it backwards. We use this. You use all this time to check your work, right? Because you guys check your work every single time. Right? You use this to check your work, you use this to help you understand things, you use this to help you rearrange to find unknown numbers. But we'll get to that a different day. All right? That whole finding unknown numbers. But we see this process, and we call that inverse operation. The inverse operation helps us understand that there are something known as fact families. So that if I give you numbers like 2, 3, and 5, I can say, okay, there's a fact family here. They work together. And so I can say 3 plus 2 is a part of this family, just like I can say 5 minus 2 equaling 3 is also a part of this family. And so we have that idea. Of course, multiplication also has these ideas, and so we can look at that, right? We know that 5 times 4 is also equal to 20, just like we understand that 20 divided by 4 equals 5. And so in this case, we have, right, 1, 2, 3, 4. Those 4 expressions go together and make a family, just like 1, 2, 3, 4. Those 4 expressions go together and create a family. All right. To show me your understanding of this, let's go ahead and try a sample problem with these numbers, right? So we got fact family number 1 and fact family number 2. So go ahead and look at those two groups of numbers and find the families that go with them, and go ahead and record that into your notes. Go ahead and pause the video at this moment and do that. From here we move into other properties that we can see. Some apply to addition, some apply to multiplication. Most of them really fit in those realms, because subtraction and division, they have so many other different rules that a lot of these properties just don't work with them. All right. However, let's take a look and see what is going on here. So start with what's known as the commutative property. And in particular, we're going to start with addition. As we look at the commutative property of addition, we're seeing that when we take A plus B, it's going to equal B plus A. And really this has a lot to do with those fact families we just formed, right? So that when I pull out an example like this, right, I can take a 4 plus a 7, right? Here's my A, my first idea. I'm adding it to B, my second idea, which means that it should be equal to B plus A. And so just like that, we're going to say, well, if this is my B, that means this is 7 plus 4. And suddenly, this commutative property makes a lot of sense. Well, yeah, 4 plus 7 is the same as 7 plus 4. And what that is saying is that the order doesn't necessarily matter when it's just those two being involved. All right, and sometimes when we get to 3 or even 4, the order isn't going to change as long as we're getting to the same idea at the end. Right, commutative is going to look very, very similar, right? A times B is equal to B times A. So that when we pull out this problem here, we have this idea that 4 times 7, of course, is the same as 7 times 4. And by looking at those expressions, we see, oh yeah, that makes sense. We can mix them up. It doesn't matter what order. This is very, very different when it comes to division and subtraction, right? If I were to take, let's start here because it makes more sense at this point, right? 7 minus 4, we would not say that's equal to 4 minus 7 because this is going to give us a positive 3. And this is going to give us a negative 3. So subtraction doesn't have that commutative property. And if we were to do the same thing with division down here, right, we would see the exact same thing. Commutative just doesn't work. But it works with multiplication and division. So let's store that in our memory banks and move on to the next one. The next one is called the identity property. The identity property of addition is a little bit different than the identity property of multiplication. Identity property of addition says A plus 0 equals A. And so we have this concept that, you know, way back when, you've been learning this, right? If you take a number such as 5 and you add it to 0, you know that it's going to equal, maybe you said it out loud, maybe you didn't. If you said it out loud, yeah, you're in this video, awesome. Okay, but right, it equals A. Whatever this value is, I can plug any one in and suddenly I get that. And so in the end, we get this term. The additive identity, we would say, is 0. Right? Because it goes with this identity property. And we know when we see a 0, our mind is just going to instantly say, okay, that 0 isn't going to add any value. Right? And so it's just going to be whatever answer, right? If it's 5, it's going to be 5. If it's 7 plus 0, it's going to be 7. From here, we look at the identity property of multiplication. You can see now with our little formula here, it's just a little bit different, right? In this case, we're not really talking about 0. And suddenly your mind might be saying, wait, doesn't 0 do something special with multiplication? Ah, very good. And we're going to get to that property in just a minute. But it doesn't quite work the same way, right? If we look at identity property in addition, right, it's this, right, this first idea plus a second idea equals our first idea. And that's where we get the whole idea of identity, right? In multiplication, same thing. First idea times, now 1 is going to give us that first idea again, right? So if we look at our sample here, if I have 5 times 1, I'm going to get an answer of 5, right? Just like if I were to take 7 times 1, you would instantly say, well, duh, 7, right? Because you know that. You know that because you learned the identity property. And so in the end, we come away with the number 1 being our multiplicative identity. Because when you see something times 1, your mind knows to apply the identity property and just, right? And just take that number and make it that number. Right? You're not going to sit there and calculate and stress and worry about this stuff, right? We've learned to recognize those things. All right, next property is the 0 property, right? Here's that 0 coming in with multiplication. And suddenly, I must have been up at midnight when I made this video. Not good. Go to sleep. Too late. Here, excuse me. Here we go. A times 0 is not going to equal A. That wouldn't make any sense. That would be like, all right? We know that when we multiply by 0, that it's going to equal 0, right? And so in this case, right, it doesn't matter what number you put up there. You can put 8 times 0, it's going to equal 0, right? I can put 1,000,000 times 0, and it's going to equal 0, right? And so we have this idea, right? Very simple property, but it's a property we know that when we see multiplied by 0, we're just going to go right to 0, right? So if I could put a series, right? 3 times 0 times 7 times 1,234, right? I can look at this. I can look at this entire expression and say, okay, I see a 3, 7. I could, right? It's like, boom, there's a 0. Identify the 0. You got the 0 property. Boom. The whole answer is going to be 0. It doesn't matter if this becomes 21, and then you multiply 21 times that. There's still a 0 here. It's going to be 0. And so we have the 0 property for multiplication. All right, here we go. More properties. Next one is called the associative property of addition. And the associative property of addition is very, very similar to the associative property of multiplication. What this says is that the order doesn't matter, right? If all I'm doing is adding, right? I'm adding, 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 adding. There's no other symbols in there, right? If all I'm doing is adding, then the order that I add things together doesn't matter. So I can take A plus B plus C, but that's the same as taking A plus B plus C, right? With those parentheses saying do this first instead of doing this first. And so if I pull out the sample problem, right? We can use the word grouping, right? If I'm grouping things, sometimes I'm going to notice a grouping that I find easier than something that's not, right? I can say, okay, 3 plus 5, that's 8 plus 4. These are all small numbers. I don't think this math is sitting there saying, getting your mind racked and just no idea what's going on. But you're like, okay, this is easy math. Why is Mr. Fisher telling us this easy math? And it's like, well, first of all, we're just reviewing these properties, right? We're jumping into 7th grade math. And as we jump into these, right, suddenly it's going to be x plus y plus z. And then you're going to get values for all these things, you know, x equals 12 and y equals 5 and z equals 30, you know, and suddenly you got to ask yourself, which is going to be the easiest way to solve this? Should I take this first? You know, should I take this first or should I take this first? What's going to be easier? Because it's okay to rearrange things because, ding, 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 associative property of addition. And this associative property of addition is very, very similar to the associative property of multiplication, right? It's the same thing. When we have just multiplication, what we can do is we can multiply things in an order that makes sense, makes it the easiest. And so when we pull out problems like this, we can say, okay, I can take 3 times 5 and get 15 and multiply by 4 and get an answer. And that's okay. But it's also okay to say, well, 3 times 5 times 4, 15 times 4, I can do that math. But you got to ask yourself, which is easier? 15 times 4 or 20 times 3? They're both going to get you to the answer of 60, right? But chances are that by rearranging them, by looking at them different, at least in my mind, this mind says, I can do this faster than this because I'm just not used to multiplying 15. And 20 is a power of 10, or a 10 base number, and so I can do 10 base numbers, you know, in my sleep, you know, with my eyes closed. All right, maybe I'm exaggerating with my eyes closed idea, right? But we get that concept, and that helps us out. So now we've looked at all these things, right? We got the associative property, we got the 0 property, we got the identity property, we got the commutative property, inverse operation. Whew! I'm just talking. The video's not over yet. What? We can use this idea to help us to, I'm going to call this a basis for a proof. Can I prove this statement? Prove why I get from step 1 to step 2 to step 3 to step 4, step 5, and whatnot. And I can look at all these different ideas. And so if Donna simplified 4 times 15 times 25 with those parentheses under between the 15 and 25 in 4 steps. Wait, she took 4 steps to do that? Justify each step. All right? Now this is something new. We've never really necessarily had to do this. You've done this in mathematics. You've used this before, but you've never labeled it. Right? So as I look at this, I say, okay, if this is where I started, this was my my initial, right? What did I do to get from here to step 1? What did I do? And you can notice that I switched the places of the 25 and the 15. So which property says to do that? And instantly, maybe not instantly, you might say, well, that's the commutative property of multiplication. My pen is not sticking with me, right? It's a commutative property. Commutative property says I can change the order and it's going to get me to the same answer, right? Step number 2, you see how the parentheses move, right? Now they're over here. And so what's happening here? Now we're using the associative property, right? And what that is saying is that the associative property says I can do this section before I do this section, right? And I'm still going to get the same answer. So the associative property of, I'm going to shorten version of multiplication. And so finally we say, okay, what did we do next? In step 3, suddenly we're left with 100 times 15. Well, what did we do? Right? We multiplied 4 times 25. That's how we got that expression, right? We actually did what was inside those parentheses. And finally, of course, the last step, how do I justify this, my final answer of 1500? Well, of course, all I did was, right, I multiplied 100 times 15. And so I got that final answer for this problem, which enables me to say, yes, 4 steps, got it done, justified. Right? And so I multiplied, and I gotta write those in, I gotta write words here. I can't just write the expression, I gotta write multiplied. Right, to say this is what I multiplied 100 times 15. Alright, so this is what we call, some people would call it a proof. I'm proving why these steps are what they are. Okay? So, sample problems to get us through this then. Alright, so here's your samples, they've come at the end this time. First of all, step 1, name the properties illustrated. So what property is this? What property is this? All right. Second, it says name the property to find the unknown. So name the property, right? Key answer is, I'm not looking for an answer. I'm not looking for a 0 or a 1 or a 2 or a 12 or whatever number it might be. I want to know what property, when you look at this, you know what property it is, right? And so once you've done these 2 problems, right, pause the video to solve these, then go ahead and do this proof also. All right, and I'm going to scroll like this for just a minute, let you see the first few steps. You're definitely going to have to pause the video. All right, and I'm going to scoot it down then, and now you should be able to solve this, right? So name, prove why this is correct. Whew, 7th grade math takes a while. Right? These concepts aren't new, but we want to get them all down. We want to get them all fresh in our minds and using them right away so that as we continue in our math, we just, boom, we're on track. We're doing them. We got these. All right, that's it for lesson 7.2.